Okay, I'm going to deal with the proofs of some result. As I said, scalar product, the way I define A dot B is a definition, you don't question, but the result that follow, there can be some proof. This is entirely optional, but I feel that if you can spend some time to go through it, it does help you a little bit with your workings and so on. So good if you can go through. Now, first thing I'm going to prove is the distributive law. Distributive law goes like this. All right, we do not assume distributive law. This is not a multiplication of real number. This is a dot product. I'm going to show that this distributive law holds. In order to show that, let me show the plus version will do. Okay, why the plus version will do? Because if you can show for the plus, then minus will work as well, because I can easily let C be minus C and everything should hold as well. So I'm going to show the plus version. Okay, to help me to do that, let's consider the left hand side. The left hand side goes like this. I'm going to first show the left hand side, meaning to say, let me erase this part first. Let me try and show the left hand side, which is this one. Now I draw A and B and C and A like that. If B and C are like that, then this vector here must be B plus C. Not difficult. Now, then what is A dot this vector B plus C? By definition, again definition we don't question. By definition, any two vectors, let's use U and V for simplicity. Let's not confuse. Mod U mod V cosine theta, where theta is the angle between U and V. This is by definition. So which means if I take A dot B plus C as a vector, let A be U, B plus C be V, then by definition we don't question, this must be it. It's as simple as that. But what is mod B plus C cosine theta? And what is theta here? Theta is the angle between B plus C and A, right? If I consider a right angled triangle like that, and this is theta, and this length is mod B plus C, then mod B plus C cosine theta is actually this length, which is actually this length, which is actually this length. Correct? So can I let this length be K? Then therefore this must be K times A, because I let K be equals to mod B plus C cosine theta. This length is the K I'm talking about. So far so good. Okay, that's the left hand side. That's the left hand side. I'm going to prove this is the left hand side. I'm going to prove the right hand side is equal to the left hand side. Let me show you the diagram. It's the same diagram, same B, same C, of course. But I'm going to focus now on the right hand side here. Okay. Separately, what is A dot B and A dot C? Now, again, by definition, if you see, all right, U dot V is mod U mod V cosine theta. So what is A dot B? A dot B is mod A mod B cosine angle between A and B. So if I let angle between A and B be alpha A, I beg your pardon, I let it be alpha B, and let the angle between C and A, because this two is alpha C, right? I draw one parallel line to A like that. So angle between C and A is alpha C. So it's not difficult to write this. By definition again, A dot B is this, and A dot C is this. Now, still have not shown that this whole thing is equals to this, but I'm going to show that soon. But before that, let me factorize the mod AL. Okay, because I can factorize the common factor is mod A. If I factorize the mod A out, I'll get mod B cosine alpha B plus mod C cosine alpha C. Now the magic is about to appear now. If you see very, very carefully, mod B cosine alpha B actually by trigo, if you look at this triangle, is actually this. Mod C cosine alpha C is actually this length. And you add these two together, it will happen to be K. Exactly the same. This is K. Therefore, it is K times A, which is actually the left-hand side. Shown. As you can see from the left diagram and the right diagram, they are the same. Okay? So that's the proof for the distributive law. Next is the proof for what if I have two column vectors, okay? Two column vectors. Suppose I have 1, 2, 3 dot 4, 5, 6. Why is it it must be 1 times 4 plus 2 times 5 plus 3 times 6? Actually, I'm about to show why. And we should question. First, let me rewrite this in IJK form. Okay, no problem. The column vector and IJK form used interchangeably. Next, I'm going to use the distributive law, which I have proven earlier. All right, I can distribute my addition over the dot product over addition and subtraction. In this case, only addition. So the next line is merely, I will take this one. Maybe I just take this one, dot this. Then after that, next, this one, dot this again. And then finally, take this one, dot this again. There's one layer of distributive law, and after that, you another layer of distributive law. Basically, is distribute this one across and distribute. So, not a problem. I will distribute across. So I'll pause here for a while. If you want to see how the distributive law works, you can see, which is not exactly rocket science. It is just distributive law. I distribute, so actually I get 9 dot product. I get 9 dot product. But you can see a lot of dot products are like that. You can see this one. Let's circle this one. You have something I dot something j. You have, let's take a look at this one first. What is I dot j? Let us recall, if A and B are perpendicular, let's recall. Sorry. All right. Ignore the red one in red for the time being. Let's recall U dot V equals to mod U mod V cosine theta. Now, if U and V are perpendicular, cosine 90 is 0. So clearly I dot J must be 0 because I and J are perpendicular. Similarly, I and K are perpendicular because one is the X component, one is the Z component, also perpendicular, also 0. So this one also 0. This one also 0. This one also 0. This one also 0. They are all zeros. What you are left with is I dot I, as you can see here, I dot I j dot j and k dot k. But what is I dot I? I dot I is 1, j dot j is 1, k dot k is 1. Again, what is why? Because what is I? I is a unit vector in the x direction. So I dot I, magnitude of I is 1. So 1 times cosine 0 also 1. So surely it must be 1. So end up with this result here. You may want to rewind this. I went through it quite fast. You may want to rewind it to fully understand. Thank you.